because every day at lunch you were like you.
Well, that's what I was telling her. I was like, that's how I remember having you at lunch.
And you had Julia.
Mm-hmm.
Yeah.
Mm-hmm. Yes, I did have her for 2 years.
Because I didn't drink any of.
All right. So today is question answer review. I'm going to go through some questions that were posted to the form. There's a lot of them that I'm going to kind of talk. Some I might go through more in depth than others. 7C is one that I'd like to talk about. Kind of talk about but not go through. 13, D and F. Those are two fraction problems. They are really good problems. So I'm going to look at those two problems. I'm going to look at number 14. And then 15 as well. So I'll go through pieces. I might not do all of the problem, but kind of looking over those questions. So if you want to take out the review so that we can look at some of those questions, a little bit about the test tomorrow, and this is especially for those of you that are at home. If you're looking at my screen, which hopefully you're doing, tomorrow's test, those of you in class, you'll be taking the class still using your iPad. I'm not going to use a paper test until everybody's back. But I do want to, I will be giving paper tests once everybody is back. Just as a math teacher, I think it's easier to grade looking at a physical piece of paper than staring at a screen. And I think you'd probably rather take a math test on a physical piece of paper than maybe on the screen as well, or through a form, or a website, or whatever. If you are at home, the test tomorrow, you'll be taking in class with your other peers if you're at home. But the key thing is that I want you to join Zoom. So I want you to come and join Zoom, and I think I have this right there, during the test tomorrow. And I want you to have your camera on. So this kind of enables it to be a little more fair for those of you that are in the class versus those of you that are at home. So what that means if you're at home, you need to run Zoom and Google Classroom, or not Google Classroom, Notability at the same time. So you'll have to screen share. Yes, it can be done. You can screen share Zoom and Notability at the same time. Just make sure your iPad has been updated. So your iPad needs to be completely updated. The Zoom app should be updated. And then you can screen share Zoom and Notability at the same time. Or your other option would be to run 2 devices. So have Zoom on your phone and use the iPad and complete the test on Notability. Again, it doesn't, like, you guys are in my class, no big deal. But for those of you that are at home, you will log into Zoom tomorrow. I will have it open right away, 1:15, 1:13, whatever time it is. And you will come into Zoom, keep your camera on. The students in the class will not be able to see you, only I will see you through my iPad screen. And then you will take the test, still connecting to Google Classroom and completing it on Notability. If you have questions with that, concerns about that, send me an email. Are there questions about the test tomorrow? So it's going to be like a regular math test. So.
I might not be here or like on the Zoom. I'm gonna go to Zoom details.
So then you need to email me and schedule a time when you'll be taking it. Other questions? I would say try and take it before you get your wisdom tooth out, but that might not be possible. But think about it, send me an email so that I can schedule a time. All right, so we are going to look at the homework. So starting with the review. I'm going to talk about number 7, but we're only going to talk about it. We're not going to go through all of number 7. But I need you to understand the difference of finding an inverse or verifying that 2 functions are inverses of each other, because there is a difference. So I want you to kind of understand that there is a difference between the 2 types of questions, so that when you see that question tomorrow, you're kind of understanding what the problem is asking you to do. So that is right there, number 7. Algebraically determine which sets of functions are not inverses of each other. So I don't want them to be an inverse, but it's talking about a set. So I have 2 functions. I already have 2 functions. I'm not finding the inverse. I'm determining if they are inverses of each other. Algebraically, how do you show 2 functions are inverses of each other?
By doing f of g of x and g of f of x.
Right. And it has to equal?
X.
That is the definition of inverse functions. 2 functions are inverses of each other if and only if f of g of x is equal to x and g of f of x equals x. Not by the fact that if I switch the x and y and I get back in y equals form, that one equation matches the other. That's the way to find an inverse. But to show that you have 2 functions already and they are inverses of each other, the way I find them that they're inverses is by taking f of g of x, g of f of x, and making sure it's equal to x. So that's the definition of an inverse function. That's how you would show that 2 sets of functions are inverses of each other. So if we look at C, if I try and do this, what Adam said, I'm going to use the letter C here. So I have f of g of x, that's the composite function. If I take the g function, which is the square root of 1 plus x squared, and then I have to plug that into function f. Well, function f says 1 minus something squared. Well, that something is my g function, which is 1 plus x squared. So this is how we do f of g of x, a composite function. We're trying to verify these 2 are inverses. So Gabby, if I have a square root and my quantity squared, what happens?
They cancel each other out.
Yeah, they cancel each other out. So cancel, cancel. But that quantity is still in parentheses because there's a minus sign in front of it. So the square root and the square cancel, but I'm still subtracting this quantity, which means I have 1 minus 1 minus x squared, which becomes a negative x squared. So that's just the process of a composite function, which is good to review. Taking one function, replacing it into x of the other function. Based off of the definition you gave me, Adam, would these two functions be inverses of each other?
No,
Why not?
because it has to equal x and only x.
Right, it has to equal x and only x, because graphically they're reflections of each other over the line y equals x. So once you do this and you don't get an x, you're done. I now know that part C, they are not inverses of each other, and that's what the question is asking for. Which of the functions are not inverses of each other? And that would be part C. When you do the other two, they both end up equaling x. But one could be x and the other way might not be x. So make sure you check both ways. It's a condition if and only if statement. Questions? All right, so that is showing that it algebraically that sets of functions are inverses or not inverses of each other. So if we continue on, looking down here, I'm at number 11. This question is asking you to use a sequence of transformations, and then it says in order, that will yield the graph of g of x equals negative absolute value of x plus 9 from the original graph f of x equals the absolute value of x. What's this really asking us to do? Matt, what's the question asking us to do? Yeah, describe where the graph moves. Now it does say in order because there is really something that you're supposed to do first and then something that you would do second based off of order of operations. So the first thing that you would do with this graph is the part that's being multiplied. So if there was a 2 in front or a negative sign in front, multiplication is performed before addition and subtraction based off the order of operations. So Matt, that negative sign in front, what does that do to the graph? Yeah, so it takes my positive graph, it reflects it downward. It's making it negative. The graph's being multiplied by a negative y or a negative y value. So my graph should reflect first. That would be step 1. And then Matt, how else does the graph move? And it moves left because really that's an x minus for my standard form and then a negative 9. So those will be the sequence of transformations. So if I start with the absolute value, positive, I'm flipping it and then shifting it to the left 90 degrees. Daniel, question? Thank you.
Yeah, so in that case you would not treat it like x plus 9 and then you flip it horizontally. That's not what you would do. It's still
It only would get flipped horizontally if there was a negative inside with the x variable. So there's
Okay.
2 different places you could have a negative. So you could have it outside, that flips it left or right. I'm sorry, up or down. The one inside is affecting the x, so that's when it would go the opposite way. So you gotta look at the portion of the negative sign. Did that answer your question?
Yes.
Okay, good. Other questions? All right, so we are going to go to the hard problem. And it is pretty challenging. Number 13. I threw some fractions in the problem. Would you have one as involved in this problem tomorrow? No. Could there definitely be fractions? Yes. I would say the fraction or the function for f, 1 over x, is a fairly doable function. I know it's a fraction, but at least it's number 1 on the top, coefficient on the top, variable on the bottom. G of x, this one's a little more challenging because we have an expression divided by a different expression, so the g of x function is a little challenging. We're going to work through part D, and then we're going to work through part F. So this wants us for part D to find f divided by g of x. So Cassidy, what do you think we'd have here, f divided by g of x? What would we do?
It would be 1 over x divided by 3x minus 1.
So we would have one over x, and then she said divided by, and then she said 3x minus 1 over x minus 2. Anybody know what the name of this is called? It's a special type of fraction. It's called a complex fraction because it kind of does look complex. It's a little daunting. So as I said, would you have something as difficult looking like this? No. Sometimes I try and make the review worksheets a little more challenging to up the ante, and then hopefully the test seems not quite as difficult as the review. So when you have this type of fraction, a complex fraction, let's think of it as parts. First of all, a fraction bar divides a fraction or one number divided by another number. That's what a fraction is. 2 divided by 7 is 2 sevenths. I could also say it is 2 divided by 7. So I could take this fraction and write it like old school division, like that little old division sign, the first division sign that you learned. 1 over x divided by 3x minus 1 over x minus 2. In math, there are always multiple ways to write things. So now I have the same fraction, but I took the division bar, the fraction bar, and made it into a division sign. In chapter P, we talked about dividing rational expressions. How do you divide a rational expression? Cassidy, how do I divide a rational expression?
You change
Say it again.
the if you change flips, it would be 1 over x times x minus 2 over 3x minus 2.
Yeah. Dividing is really multiplying by the reciprocal. That's what dividing is. So when you divide, you're really just multiplying by the reciprocal. So change it from division, make it into multiplication. So really we're taking the reciprocal of the denominator, making it multiplication. And then when you multiply across the fraction. So top, bottom. Except the bottom, I'm leaving in factored form. Fractions are simplified when they are factored. So I have an x, and then I have a 3x minus 1. Multiplication can be shown again in different ways. I could distribute that through, or parentheses also mean multiplication. So if you looked at the answer sheet and you're like, how the heck did she get that? Well, it's because I treated it like division because a fraction really is dividing, and I multiplied by the reciprocal. Now, there was another part on these problems because these are all fractions. And next to my answer, I need to think about what x can't be. Because if it's in the denominator, that number can't exist because I know I cannot have a denominator value of 0. So Thibault, what is one x value that can't exist in this equation here, or this expression?
0.
Well, yeah, it can't be 0 because right here, I have a single x by itself, and that x can't be 0, so it cannot be 0. Thibault, how about another value? 1/3. And that's because here, if I set that equal to 0, it cannot be 1/3. There's one more value, Thibault. One more number that x cannot be. If you look back up through the other separate fractions, where else is there a denominator, something in the denominator?
2.
The 2, yeah. So right here, this is still a fraction. It's still in the denominator. It's in the denominator of the denominator. So it's also cannot be 2. Those are restrictions on x that we will write anytime we have a fraction. We're restricting the value. We're saying x can't be this because I have a fraction in my problem. So you're looking at the answer, but then I have to look back and see any function that initially had something in the denominator that also was restriction on x, because I could evaluate first with the initial functions, or I could evaluate last with my answer. Questions? So again, you may see fractions tomorrow, but I would say probably not like this. But like fractions are in math. Math is fractions. Fractions are in the world. Like, I mean, everything's a fraction. Not everything, but a lot. All right, the other one I wanted to look at was f. So if you take a peek at f, I'm going to just rewrite f so I have some extra room. So f says g dot f of x, which immediately my mind is saying rewrite, rewrite, rewrite. So I'm going to rewrite this as g of f of x. And I know from above, f of x is 1 over x. So in my g function, I have 3 times x minus 1, x minus 2. So that's my g function. I'm plugging in 1 over x. So 1 over x, 1 over x. That part's the easy part. If I could just leave my answer like this, that would be wonderful. But again, that's not simplified. So Sadie, if we try and simplify this, there's a 3 times a 1 over x. What does that mean?
That you have to distribute it. So
Yeah.
3 over x.
So it would be 3 over x minus, and I'm going to make this 1 over 1. I might as well. If I have a fraction next to it, let's make it look like a fraction. Got our big fraction bar. And then on the bottom, we have 1 over x minus 2. And I'm going to put that over 1 as well. Crappy one. All right, Sadie. So I got 4 fractions now. What do I have to do with those fractions to try and combine them?
Get a common denominator.
Yeah. So we have to combine these to simplify. Get a common denominator. What would that denominator be? X. Because there's an x here, so my other ones need an x. There's an x down here, so my other ones need an x. When you subtract or add, you have to have common denominators. Once the denominator is the same, you combine the top together. So I'm taking the 3 and the 1x. They get combined together in my fraction. There's a minus sign in between. So now the numerator says 1 fraction, 3 minus 1x over x. The denominator doing the same thing here, combining my pieces, 1 minus 2x over x. All right, so if you look at these denominators, Sadie, what do you notice about them?
They're the same.
Yeah, they're the same. My denominator of the numerator and the denominator of the denominator are the same. They cancel. So if the denominators are the same, or if the numerators were the same, they cancel each other out. Because really I'm multiplying by the reciprocal. That's why they cancel. So my final answer is whatever's left on the top here, which is its numerator, and then the part on the bottom. Remember, this can't be simplified further once I have it in fraction form and I've combined the pieces. God bless you. Because this is an expression that has to be held together. Think of invisible parentheses around it. The last part, really hard problem. We did all the work. Let's make sure we finish the work. Adam, what can't x be?
Well, for stars, it can't equal 0.
Right, can't equal 0 because I did have a 0 or an x here, so can't be that. And
1/2.
1/2, and that's because of my answer right here. Still has a 1/2 value that would make the denominator 0. So again, when you're looking, go back to what you started with. Like right here when we started, we had a 1 over x. So I have to look at that starting point and say, is there something in my denominator ahead of my simplified answer? So I need to look at the answer, but we also need to look at like where we started. Questions? Really challenging problem. A lot of math skills involved in that. Simplifying like terms, multiplying by the reciprocal, using composite functions. A lot of math involved there. Algebra. Any questions? All right, so I think 15. Oh, I wanted to talk about this one because as I was looking over homework, I want to make sure everybody's good with this. So 14, I'm not going to do this. I'm just going to talk briefly here. Using the definition of an inverse function, verify the following functions are inverses. So it's saying they are inverses. It's not telling you to find the inverse. I need to verify, show, prove, why are these inverses? So why are they inverses? How would I know that? That's what it's asking. Anybody know how you show they're inverses?
Do f of g of x and g of f of x.
Yeah. So f of g of x, g of f of x. That's verifying functions are inverses of each other. So this is like number 7. So just don't go through and like find the inverse of f. Find the inverse of g and be like, hey, look, they're equal, so they must be inverses. No, they're inverses because the composite functions both ways equal x. So that's why a pair of functions are inverses. Make sure you understand the difference between verifying and finding. Verifying is proving using its definition. Finding is just switching x and y and solving for x. I'm sorry, solving for y. All right, I went over a lot of stuff. Before we go over the last problem, are there questions on anything so far? All right. So I don't know which one of these last ones you want to go over. Which one did we do in the other class? It's a B.
I think we did B.
So we can do B. I can do another one. Are there one like an option that anybody has to go over for number 15? Doesn't matter to me. Matt?
I just want to do B.
B? Are you sure just B? Yeah. All right, let's look at B. So looking at B, it's different than A, C, D. I think this one's different than most of them, right? Yeah. So B is the only one that's different. And the reason it's different is where the symbol is located. Remember, that's your inverse function symbol, and it's outside the parentheses. Whereas A and C and D and E and F, it's attached to the actual function. So Gabby, what would you do first for B?
Find f of g.
Yeah, we need to do the inside. We're going to find that part first. So using the functions, I'm not doing inverse yet. We're just finding f and g, f of g. So x plus 5 is my g function. My f function says 3 minus 2 times x. Well, we just said x was x plus 5. So we're just using the regular functions. We're finding f of g of x. Then we simplify 3 minus 2x minus 10. So this is negative 2x minus 7. Sorry for the delay. Must be writing too fast for the board. So now this is f of g of x. Gabby, what would we do next?
You would find its inverse.
Right. That inverse notation. Now that I found the inside, I want to get the inverse of this composite function that we just found. So to find that, I know I have to switch x and y. So this is now x equals negative 2y plus 7.
minus 7.
Oh, thanks. It is a minus. Doesn't switch yet. Here we go. All right, here's the little trick. We need to solve for y. Right now, y is negative. If you move y to the left, because usually it's y equals, move x to the right, then that makes my y term positive. So I would have positive 2y equals negative x minus 7. It's a little trick there. Make your y term positive. Because then when I divide, we're dividing by a positive number. So y is equal to negative x minus 7 over 2. Or my inverse is equal to negative x minus 7 over 2.
It'd be acceptable to take a negative 1 out of the top.
Yeah, you could definitely do that. So you could say, I don't like having those two things negative. I'd rather factor that out. And that would be fine as well. But keep it together as one combined fraction. So one term, one fraction combined is simplified. Two separate pieces is considered unsimplified unless I was graphing a line in mx plus b form, but we're not graphing a line in mx plus b form. So like knowing when something is simplified, combined together. Something combined together is simplified. Something in pieces is not simplified. Other questions on 15? Are there other questions at home or in here that you would like me to go over? Yeah, sure, yes. I think I'm just gonna write it over here. So, all right, so D is saying use the inverses. So kind of looking at the different notation, we need to use the inverses to do this problem. So let's look back up here. This inverse for G, I would have x equals y plus 5. So this is just going to be x minus 5. That one's easy. All right, there's G. And then for F, I would have x equals 3 minus 2y. I'm going to use that little trick again. My y is negative. I'm going to make this y equal. So I'm going to move the y to the other side. So it's a positive y. So now I have negative x plus 3. And then I would divide by 2. So trying to keep the y positive. If you have something that says divided by -2, you probably didn't get correct answers. Because fractions, you can't have a negative in the denominator. Fractions are really picky. So if you think of moving the y term over to make it positive, then I have a positive number in the denominator. All right, so step 1, we have to get the inverses. Step 2, now we're going to use those inverses. And we're going to take the inverse of f, the inverse of g, and the number 1 for x. Remember, whatever's in parentheses is x. So I think I went up too far. What's the inverse of f? G, not g, f, no, g. G, what's the inverse of g? X minus 5. So the inverse of g is x minus 5. Except that we know x is 1. So now I have the inverse of g being just the value, I plugged in a 1, being the value of -4. So Thibaut, what do you do next then?
Plug in that
Yeah, so now I'm gonna take this -4 and the inverse of f. And that inverse says -x plus 3 over 2. Wish I had a bigger board. So -x plus 3 over 2. And to go, that makes
So,
7 halves. Squeeze it in there. So fractions are tricky. They're challenging. They're also picky. The denominators of fractions are really picky. A lot of rules, a lot of exceptions. Can't be this, it can't be that. Can't be negative, it can't be 0. You can't have a square root. You can't have an imaginary number. Lots of can'ts for fractions. Essentially, the only thing in a fraction on the bottom is a whole number when we're just talking about numerical values. So there is a worksheet posted on Google Classroom, but if you have the packet open, it's just the next page in the packet. There are answers posted in Google Classroom for this worksheet as well. This worksheet is not a requirement. I strongly suggest that you do it, but I'm not collecting it tomorrow. So the assignment that is due today is worksheet number 1. Worksheet number 2 does have different problems on it. Like I'm looking right here, number 3 is a piecewise function. A piecewise function was not on worksheet number 1. So my suggestion is to look at the problems on worksheet number 2 and think about your comfort level. Yes, this looks easy, I'm not gonna do it. Nope, this one looks harder, I think I need to practice this problem. Like looking at number 2 and the difference quotient. Some students are really still having problems with the difference quotient and how you plug that in. So kind of just going through saying, yes, I'm good. No, I'm not. I need to do one more of these. Or take the whole thing tonight as a test. Time yourself. Does it take you 20 minutes? If so, then you should be good to go. If it takes you an hour, then yikes. You've got to do a little extra work, work through some extra problems. Tomorrow's test, again, students in school, both my 3rd and 9th period are taking it in school. Those at home, you're going to still join Zoom with me. You can either split your screen so that you have Zoom running and Notability next to it, or you can run 2 devices. Have your phone on Zoom, your iPad running, so that you can use Notability on your iPad. But I need to see your actual face on Zoom if you are at home. If you'd like to receive credit for it, you will join Zoom. If you have a problem, please email me. I'll send out a reminder as soon as school is over to everybody in cohort 1 that is at home. So we still have about 7 minutes left, 6 minutes. If you have questions, let me know. Those at home, again, if you have questions, please let me know so that I can answer them. Send me an email if you think of something tonight. My daughter's softball game got canceled, so I'm not going to be at a softball game tonight.
can I run the bathroom?
Oh yeah, just scan the thing.